we got operation functions part 3, which part 3 focused on the quotient. Part 1 was adding, subtracting. Part 2 was multiplying, and part 3 is dividing. Due to just, last week being crazy, we were supposed to do this last week, so we got to hustle and get through it here. So we're going to do the same thing we've done for all 3 start of these lessons, and we're going to fill out a table that kind of compares the 2 functions and how they're growing. Okay? And so you can help me do this because they already have it lined out for you. 14 divided by 2 is 7. Okay, so f of g of x is 7 at that point. So that is a point on the new graph. So you want to go to 4 up to 7, and this is going to be a point on the f over g of x graph. Okay? Now, a couple of you guys had a homework question where these were blank and you were kind of lost. Okay, you get these from the graphs that are given to you. So this says f of x. So I go look at x equals 3 right here. I look at the f of x graph. So it's all the way up here. Looks like it's going to be right there. Okay. So 3, 6. Oh, I was the one over. Thank you. Yep, right here at 6. Okay, where the dot is. So 6. And then the g of x is at 1. 6 divided by 1 is 6. Okay, so that's how we build that there. Okay, I want you guys to go ahead and do a few on your own here. I'll walk around and help if you need help. I'm going to talk about let's get these down here. All right, so you guys did really good on all these. In this one, we have an issue. Okay, a couple of you left it blank, so you're confused. Okay, but here's the problem. What's anything over itself? 1, except for 0. So the problem is you are still dividing by 0, which is you can't do that. It's undetermined. You can't divide by 0. So anytime we run into this issue, and with division this happens a lot, where you get to a point where you're going to divide by 0, it's going to be undefined or an open circle. Okay? So what we put here is we put undetermined, okay, or undefined, or whatever you want. The book says undetermined. I usually use undefined, but I'll stay with the book. Undetermined. So what that means is we have no value at 2 for x. Okay? So now let's look and plot these points, and then we'll kind of talk about what we're going to put there. Okay? It does tell you at the bottom there what you're going to put. Okay? Let's see. We go 6. So it's at 6 here. We don't know at 2. At 1, it's at 4. So it looks like, and then what? Oh, okay. And then 0, it's 3. So it's definitely going up. Look at that. It's a slope up 1 over 1. Okay, it's going up 1 over 1 for the slope. Does everybody understand that? So I can just keep going this way. So that's why -1 is 2. -2 is 1. -3 is 0. And then we're here. So here is my line. Put a spot there. Okay, this right here, we put an open dot to represent that. That open dot represents that there's no value there. It's like a hole in the graph. There's a hole in the graph there because we cannot divide by 0, which in that case for g, that's the 0. You kind of see that, can't you? Because right here, it's the x-intercept of the line that we're dividing by, is 2. See right above it? Oops. 2, I'm 1 spot over. This part's good. It's this one. It should be 5, right? It should be 5, but we don't have a value there. Okay? It's right above it. Okay, my line looks worse now, but okay. Any questions on that? That's the one tricky part with division. You're going to have undefined values now because you have opportunities to divide by 0. Now, this is back to the refresher. So we had a quadratic, we divided by a line. So think about it. I had an x squared, I divided by an x. So what happened? What was the result? An x, right? I had a parabola, I took out an x, I divided an x out, I have one x left, which makes it linear. See this? It's linear, right? So we dropped a degree, didn't we? Our f went down a degree because we divided an x out. Okay, understand what I'm talking about in terms of operations now. Okay, so multiplying, we're adding stuff. We're going to be giving it plus degrees. Dividing, we're going to be taking degrees out. It's going to be getting a smaller degree. Okay, awesome. All right, guys, I'm going a little bit too elaborate. Maybe you're bored because it's easy, or hopefully not bored because you don't know what you're doing. But okay, so explain why domain of function is not XER now. So we pretty much talked about this. Why is the domain of the f over g not x equals r? Because it's linear, right? Because of that hole. It's everything but that hole. Okay, so you're going to write it two ways. I'll write both. I'll do set builder. So it'd be x is, essentially x is, we can do, let's go, x is greater than 2, and x is less than 2. It's everything but 2. That's what that means. X greater than 2, x less than 2. So it's everything but 2. Okay, interval notation, you can write it as okay, so all round brackets, we're not including 2. That's simply just saying negative infinity to 2 but not 2, not 2 but 2 to infinity. In union just means connected because we have two intervals. Okay. The U stands for union. Okay. So sketch the graph of f of g. We did that up above already. We put the open circle. Functions f and g above f of x is x squared plus x minus 6 and x minus 2. Write and simplify an expression for them. So they want us to actually set this up now. So we're going to go this on top divided by this. So we're going to go x squared plus x minus 6 over x minus 2. Okay, that's where it kind of gets kind of cool. Does the top factor? Does the top factor? Yes, okay. Come on, math 30s, guys. That's an easy factoring. We should all be like, yeah, that's simple, no problem. Okay, x squared plus x minus 6 does factor to x plus 3, x minus 2. Well, what do you think happens to the x minus 2's? They cancel. Well, what's that line up there that we have? That line up there is x plus 3. Okay, so that line that we just graphed up above, that new one, is the line x plus 3. The only thing we have to count for is what do we cancel? An x minus 2. So 2 can't have a value. We can't put a value at 2 because we canceled out. So that hole comes from that canceling. Okay, are we staying with me? Staying awake on a Monday? Because essentially it's because we eliminated, like we canceled something, but it's still there. Like it was still a part of the function, right? So even though we canceled to simplify to see what's left, we still, if we go back to the beginning and we plug in a 2, we're going to get 0 over 0 and it's undefined. Now, in calculus, you're going to prove that it's approaching the same number from both sides. So you can say, well, it's 5. It's going through 5. Okay? In calculus, that's kind of what you'll do. Okay? But for us, we're just going to identify 2 is a problem. It's just open circle for us, so we know it's everything but 2, but essentially the line x plus 3 is our new function after we divide. It's going to, yeah, well, yeah, because if you count something it's on the bottom, that's the problem, right? Because that's the dividing by 0 problem. Yep. Okay? F over g of negative 6 now. So now we can plug in negative 6. Well, what is that? Well, we can just put that in right here. What's negative 6 plus 3? Negative 3. Because we can't put it in. Okay, and if you put it in over here, it would have been the same thing. Okay, so if you put it before simplifying or after simplifying, it'd be the same, right? Because if I put in, let's just do it, okay? Negative 6 plus 3 is negative 3. Negative 6 minus 2 is negative 8. Negative 6 minus 2 is negative 8. I won't even multiply those. The negative 8's to cancel. You still get your negative 3. I'm just saying that either way, you're going to get that same negative 3. Okay? Don't let me over-explain and confuse you, okay? Ask questions. I just want you to see that both sides. We plugged in the negative 6 into the simplified version, and then we plugged it into the unsimplified version, and we still got the same answer either way of negative 3. That's all we did. All right, let's go on here. Let's get to the, if you don't like the investigation part. So it says, in the investigation of the graph, f over g of x cannot include the 0.25 since there's domain restrictions, x can't be 2. So to what Aiden said, we can't include it because in the beginning, it's part of our domain restrictions. It's kind of like when you make your domain at the very beginning, it's kind of set. We can't just say, oh, we canceled it, our domain changed. It's not going to change. Okay, it's still the same function. This point results in a hole of the graph, and they do call it a hole. That's why it's an open dot. We refer to this hole as a point of discontinuity. So essentially what that means is your graph has a gap, has a spot where it kind of breaks. Okay? And that's why it has a hole in it. So point of discontinuity. Your diploma will use that language. It will say discontinuity. You need to know what that means. Okay? All right. So we'll get into this more detail with rational functions, which is unit 4 or 5. I forget. Okay? All right. So it says, in this investigation, the quotient of the quadratic of a linear function simplifies to a linear function with a domain restriction. This is not always the case. So, like, as again, back to Amos saying, he's asking a good question. That canceled, that was nice. It doesn't always happen. Okay, you can still divide something that factors that doesn't cancel a factor, and it's still going to be a linear model. Okay, so they're not always going to cancel out smoothly. Okay, okay, let's go and look at these actual examples. All right, in each case, write and simplify where possible the expression for f of g of x. Include any domain restrictions. Okay, so what we got to do is, when we do our f divided by g, we have 2x plus 5 over x plus 5. So right away, what's my domain restriction? I know what it is. Negative 5. I can't have negative 5 because negative 5 gives me 0 on the bottom. That's your domain restriction. You're done with the domain now. Okay, so let's do that first. So my domain, you also, instead of writing it the long way, you know how it's xer? The easy way to write the domain here is just x can't be negative 5. You can write it like that. So you don't do the double interval or the set builders. It's a lot shorter. So kind of, Bobber, kind of how you like xer. This is how you say not a number. So x not negative 5. That's your domain. Okay. Can that cancel at all? Can we simplify anything? What's that? The 5 does have a 2 though, right? So we can't on that one. Okay, a couple people like to hack off the plus 5s. That's not possible. You can't do that. Okay, so don't. This is all it is. We can't do anything. Okay, there's no factoring. Yeah.
Restrictions only on the bottom, right?
Yes. Restrictions are on the bottom, unless there's a radical or something on top, but that's a little bit more advanced. Okay. All right. So let's try the next one here. So one thing, this is linear to linear. Okay, it was linear to linear. So it was the same degree. Okay, so I'm going to keep in mind. All right, this one, quadratic to linear again. So we have x squared minus 2x minus 35 all over x minus 7. So we understand domain is x can't be 7. Okay. Does a top factor? Okay, good. So we do get the nice smooth cancel here. So that means that this quotient ends up being an x plus 5 line. Right? It's an x plus 5 line with a hole at where? 7. Great. You guys hear that? It's the line x plus 5 with an open circle at 7. Okay? Good. C. Ooh. We're going to have 2 problems, huh? Look, we got x minus 2. The bottom is x squared minus 5x plus 6. The reason I can say 2 problems is because it's quadratic, right? The bottom does factor. They're giving you some basic stuff here. So what's your domain here? Yep. So domain restrictions of 3 and 2. You can just put a comma, just like that. It's fine. Okay, the x minus 2's cancel. So the simplified is 1 over x minus 3. Not too bad. All right, any questions on that? All right. You guys are boring me with how quiet you are today. All right. So consider a function 2x squared minus 13x minus 7. G of x is 2x plus 1. Okay, so state the domains for f and for g. So the domains for f and g is all of our numbers, right? They're talking about them separately. This is a parabola. There's no problems with the domain of a parabola. This is a line. There's no problems with the domain on a line. So this one's simply just the XER for both. So make sure you understand the question there. But now, when we do the f over g, we now have a restriction. That's what they're just trying to get you to point out. So we have g 2x plus 1. So what is my restriction now? Negative 1/2. Good. Yep. Negative 1/2 is right. Okay, so we know that domain is x can't be negative 1/2. Okay, so now back to, you probably don't like this one, but we got to do the AC method, or however you learn to factor this. Okay, we need to factor that top to see if we have a cancellation here, because it wants the simplest form. So this right here, I always go a times c is negative 14. Factors negative 14 to get you negative 13 is negative 14 and 1. And so you break it up. And if you have no idea what this is, that's okay. I can explain it, but whatever you do, you can go ahead and do yours. What I'm doing is I'm taking this middle term, I'm breaking into 2 terms so I can factor by grouping. So because negative 14 plus 1 is what? Negative 13. So I haven't changed anything. I just wrote it differently so I can simplify. So now watch what happens here. This is kind of the neat part. What do these have in common? 2x, right? So I take 2x out. That gives me x minus 7. Okay, do these have anything in common? They don't. They don't have anything in common. So if they have nothing in common, you write a 1. I'll just write that x minus 7 now. I might take the 1 out. Just that's what it is. So now look, the x minus 7's match. That's a factor. And then the 2x plus 1 is a factor. See these? 2x plus 1's a factor. It's because if nothing comes out, we just say a 1. Because you can take a 1 on anything, right? So since they don't have anything in common, we just call it a 1. So really, you didn't take anything out. A 1's there. I just wrote the 1x just in terms so you could see negative 14 plus 1. Yeah. Okay. Anything else? And so that's it factored. So now we see what cancels. The 2x plus 1s. So the simplified is x minus 7 with a domain restriction of negative 1/2. Okay, domain restriction of negative 1/2. So that means there's an open dot at x equals negative 1/2. Okay. All right, 2 different ways. So let's do this one out loud. 2 different ways, we'll only do one of them. Okay? You can plug 3 in to the very beginning, or you can plug 3 in now. Okay, after the simplified. Okay, you should get the same either way. Okay, in this case, you're going to get what? Negative 4. Yep, negative 4. Okay. All right, good. Okay, we just got a little bit more here. A couple more examples, and we'll stop here. I'll let you guys work for a little bit, and we'll start lesson 5 today. Okay, consider these functions. 2x over x minus 1 and g of x is x over x minus 3. Okay, so now we're doing a little bit of multiplying of rational functions. We have fractions in our functions. Okay, so what's the domain of f now? Yep, domain is x can't be 1 for f. Good. What's that? Oh, you're talking about common denominator. If you have that's something different. Okay, g, x can't be 3. Okay, good. Now we want to evaluate 3 times fg of 2. So we got to multiply f and g, put 2 in, and then multiply the whole thing by 3. Okay, so let's look at that looks like. So we're doing f times g. Now, I suggest not foiling these. Okay, just leave them at the bottom, so I'll show you what I mean. So if we're doing fg, because we multiply, you go straight across, right? So 2x times x is 2x squared. And then I would leave the bottom as is. The reason it's nice to have these as is because you can see your domain restrictions, okay, and it's easier to plug in. That right there is what fg is. Okay. Now we're ready to plug in the 2. Okay, so if I plug in the 2, 2 times 2 squared, 2 minus 1, 1, 2 minus 3, negative 1. So we get 4, 8 on the top over negative 1. So we get negative 8. And what's the last thing we have to do? Times it by 3. So we get the negative 24 is the solution. Okay, kind of putting it all together there. Now you're going to see why adding and subtracting is not as fun. Okay? Adding and subtracting is what you're talking about, Aiden. We have to get a common denominator now. X minus 1, x minus 3. We can't add those fractions. They're different denominators. This is where it gets a little bit ugly. Okay? So let's look at this one. All right. Okay, I'm going to pause it just for a second. So I said this is the harder one, f plus g, because, guys, we have to add them now. They don't have a common denominator. So if you don't know what I'm talking about, it's 2x over x minus 1 plus x over x minus 3. You can't add fractions unless the bottom's the same. We know that. That's grade 7, 6 stuff, whatever you learn, the common denominator. Okay? So we need to get them the same. So we need to multiply this by x minus 1, this by x minus 3. To top and bottom. Again, you do anything you want to a fraction, all you do the top and bottom, right? It doesn't change anything. So don't FOIL the bottom. Leave the bottom as it is. Let's actually make this a little lower here. So let's go bar. Okay. You do need to distribute the top. 2x squared minus 6x there. Plus, same bottom, that was the point. Distribute x squared minus x. So now we're going to combine like terms on the top because the bottom stays the same. 2x squared plus 1x squared, 3x squared. Negative 6x plus a negative 1x, negative 7x. Okay? And then I like to, just when I'm doing these so I don't get tedious, I just kind of put italics here. I know it's down here. Don't have to keep writing it. If you like that little shortcut, you can do that. Now pull the x out, and then we're done. Unless something cancels, which it doesn't look like it does. Okay, so with this, by adding these functions, what restrictions do we have in the domain now? Right, so we picked up one, right? So x can't be 3, x can't be 1, because we combined the functions. So domain, 3 or 1. Okay, we got one more for this lesson. Now we're going to divide those two. So, a couple things. Everybody still writing a little bit? Okay, I'll let you finish. So a couple things. Do you guys remember when you were doing rational functions last year or whenever you took Math 20? Okay, we know that we don't like 0 on the bottom, but if you're dividing by a rational function, we don't want 0 where? Anywhere. Because if we're dividing, if that top 0, okay, let me just give you a quick example while some of you guys finish writing. If I have 2x over x plus 3, and I go divided by, let's just say x over x minus 2. Well, the bottoms are still a problem, but look what happens. If this is if x is 0, what's this whole fraction? It's 0, right? But what are we doing? So you'd be dividing by 0, which is the source of the problem. Okay, so let me say it again. Bottom, okay, the bottom being 0, that's still an issue. Okay, the top is still an issue as well, because we can't divide by the whole thing by 0 either. So essentially, your bad spots when you're dividing is here, here, and here. All 3 of those spots can't be 0. Okay? All right, let's do it. So we got 2x. Oh, I'll write with this, I guess, for a second. 2x, x minus 1, divided by x over x minus 3. So there's your f divided by your g. Okay? So before we simplify, I think it's easier to state your domain, because I know these are the bad spots. So what is my domain now? X can equal 1, 3, and 0, yes. Yeah. Yeah, don't worry about the plus or minus. So we picked up one. We picked up a restriction by dividing. Okay, then how do you divide fractions? Flip it and multiply. Reciprocal and multiply. Good. So 2x over x minus 1 times x minus 3 over x. Okay. So however you're good with your fractions is fine. You can distribute this, but you also can see I have an x here and an x here, so you can cancel those and save yourself some work. Okay? If you want to distribute, then cancel, that's fine. But this should simply be 2x minus 6 over x minus 1. Okay? You can keep the 2 separate. It's up to you. I don't mind either. So all we did is these x's canceled, one on top, one on bottom with multiplication. 2x, negative 6. That stayed there. You can keep it like this as well. Okay? Yeah. Yeah, you should do the same thing, because you'll probably pull an x out at the end and then cancel. Yeah. You would have got 2x squared. You got 2x squared minus 6x, right? And then the bottom, you would have got x squared minus x. And they both have an x, so you would have pulled an x out and then canceled them. Yeah. Okay? All right, good. So we'll stop there.